Hello everyone, this is Ambush Dikshit and my registration number is CS17, and today I have been given a task to implement selection sort as well as insertion sort in C++. Now, first of all, I'll try to explain the concept of selection sort with the help of this illustration over here. Now, this is an unsorted array which we have been given, and what selection sorts algorithm is, it basically starts with the first element, that is the 0th element, and it compares all the elements in the remaining array of the smallest one. So as you can see, it starts with 14, 33, 27, 10, 35, 19, 42 and 44. It first of all starts with 14 and checks whether an element is smaller than 14 or not. Yes, it found that 10 is smaller than 14, so what it does is it swaps 14 with 10 and we get this array. Now the next thing is, it starts with the next element, that is the second element, and it compares other elements, the remaining ones, to if they are smaller than the second element or not. Yes, it found that 14 is smaller than 33, it swaps with it. Similarly, this same process repeats till the array is sorted. Now without much further ado, I'll show you the program which I'll show you the code through which we can show selection sort. Now as you can see, we have declared we have passed two arguments, an array and integer size. Okay, now what we have declared is a small temp and loc as integer variables. We have used for loop. Now we are taking as an we are taking an array I, a of I, and storing it in small, and I gets stored in loc. Now again in a set for loop, what it does is, I have put in condition over here. If this array is less than small, then j is assigned to loc and aj is assigned to small. That is the swapping thing, and this is the same thing which we are going to do if this is not the condition. Now as you can see, this code helps us to achieve the algorithm which I just showed right now. Now let us go for insertion sort. The concept of insertion sort is again, it's a bit different than selection sort. The algorithm goes like this. Let us take this array again for an illustrative purpose. Now when we start comparing with the first element, what it does is it compares first two elements and checks whether the first two elements are sorted or not, that is whether they are in ascending order or not, and it finds that in this case that yes, they are sorted. So the first element goes into the sorted sublist. Okay, now the next thing what it does is it again takes the second element and compares it to the third element, and if it is smaller than that, it swaps it and again puts the second element into the subsorted array, and it compares the subsorted arrays again. Now 14 is compared with 33, and it checks whether this is sorted or not. So what basically it's trying to do is it's gonna compare two elements, and if they are swapped, it again compares in the subsorted array. Now this thing continues till the array is sorted. Now we can represent this with a code, and we can use as you can see, again I have passed a as an array and size. Now I've declared few more variables over here. Now here we have used is we have assigned I to j inside the for loop if the condition is I is less than size. Now if the condition goes like this, j is positive and a of j minus 1 is greater than a of j, let's swap it and decrement j of ii. That means what we are going to do is we are going to take this array, as you can see this array, and we are going to move further, and for comparing into the subsorted array, we are decrementing j by 1. So this code is very good, is very visible and very efficient one. Now I'm gonna show you the output of this program. Enter the size of the array, let it be 4. Enter the number of 1, 2, 3, 4. Now I'll show you the selection sort. As you can see, selection sort is very well visible. Now I'll continue. Enter the size of an array is again 4. Enter the 4 numbers of elements into array. Again I'll try to enter the same thing. Now I'll go for insertion sort, and this is the sorted array. Thank you for watching.